Let's talk about the graph of the inverse of a function. Remember, we had just said that the composite of the two functions is equal to x, and the inverse composite as well. This is kind of special because when you see the graph, you'll see that the functions are inverse images over each other over this line of x, which is what they made when you took the composite. So remember, if it's a and b for f of x here, the inverse point over here is going to be ba, where you switch the x and the y's. So they literally are reverse images of each other over this line of x. If we look at this function, 2x minus 3, and its inverse, which is 1/2 x plus 3, on the same coordinate system, you're going to see that they reflect over the line y of x again. But, before we go on, let's just see how they came up with this. Let's review. If I were to replace this x and this f of x with each other, or just reverse it, I'm going to have x equals 2 to the negative 1 f of x minus 3. And I need to solve for this. So I'm going to add 3 to both sides. So I'll have x plus 3. And I'm going to divide everything by 2. So that'll be 1/2 x plus 3 equals f of negative 1x. So that's the inverse. So that's how they got this, how they found that. Okay, so let's look at that graph. Here it is. Here is the original graph right here. And if you notice, here's 2, 1. The x, y's are reversed here. 1, 2. 1, negative 1, negative 1, 1, and so on. And here's our line x equals y equals x. And they are mirror images over each other. Again, if you think about the range and the domain, here is our domain. Notice that it is the range over here. And here is our range, and it is the domain over here. So let's talk about what a one-to-one function is. And that is how we figure out if something has an inverse or not. You use the horizontal line test to determine that or not. It works just like the vertical line test did to determine if something was a function, but it's a horizontal line. And if it is a horizontal line, it will work as a inverse. So if you notice this, if I were to draw a horizontal line at any point across here, it only crosses one time. So I know that this function has an inverse. It is 1-to-1, so I know that it has an inverse. This one, if I draw a horizontal line anywhere on here, you notice that it has 2 places, and therefore it does not have an inverse. And when I say there's no inverse, you can make an inverse of it, but it will not be a function in itself. This is when we're trying to say there is an inverse and that inverse is a function. So this one does not have an inverse that is a function.